Sweet. Oh, I'm kind of choppy on your end. Probably my fan's running. Let me grab some earbuds real quick and see if having that mic fixes that up, Arthur. My apartment does not have air conditioning, so it ends up being every day. Is that any better, Arthur? Awesome. Sweet. Okay. I just need to untangle these things. Cool. So some announcements. Today's quiz, or rather yesterday's quiz, is going to get lumped into today's quiz. So 6 questions probably. I'll write that after class and send that off. I'll probably give you guys till midnight tomorrow to do it instead of 5 o'clock. So keep an eye out for that. I'm writing that right after class ends. I said that yesterday, but I'll really do it today. Homework 5, not out yet. Wasn't feeling super great this morning, so I didn't get that sent off. Expect that tonight. Gonna do that right after the quiz. Shouldn't take very long. Questions are already written. I just have to kind of combine 2 old homeworks. So expect that pretty soon as well. What other stuff did I have? So I guess this is, want to touch base with you guys about a second midterm. Is there interest in one, or would you guys rather just take a final? Do you want to pad the grade out a little bit? I wanted to get some of your guys' feedback on that and what your thoughts were. If you guys want a second midterm, happy to put that together. If your guys are like, I don't want to do, another midterm, I did good on the first one, that's fine too. I could go either way. Kyle says he prefers just having a final. Same with Kate. Final is going to be, I think, consult the syllabus to be sure, but I believe it's 20%. We'll definitely have a final. So, so Arthur wants a second midterm, but no one else does. So maybe Arthur, I'll write you a second midterm just for you. Or maybe I'll make it optional. I'll think about it a little bit. Erica says we want a second midterm. So there's some kind of mixed feelings. Maddie says she'd like one. Pseudo says the first midterm wasn't bad. Presumably that means the second one wouldn't be too bad. Okay, so I'll take that into account. We're pretty mixed. I'll probably make it maybe optional if you did really good on the first one, because you're going to have to take the final, and that's going to be a lot of the same questions generally. The final will be mostly all new questions. It won't be like the first midterm where a lot of them you've seen before. They'll be a little different for sure. So be ready for that. They'll still be similar, so you're not seeing new stuff. But yeah, if we want to pad out those midterm grades a little bit, I'm perfectly happy doing that. I'm thinking probably put that out on either Thursday or Friday next week. That gives me plenty of time to proofread it, make sure we don't have any technical problems. And that one will definitely just be hopefully a 24-hour period to take that with no, barring any technical problems. So yeah, keep an eye out for that. I'll put that on my list of things to talk to Sakanya about. Let me write it down. Sweet. And then the other thing was, if you guys want to do projects, kind of on an individual or maybe even small groups, I'm not going to put a homework out for that or make it mandatory. But if you guys want to do one, if you've got some topic you want to explore more, reach out. That's going to be a good opportunity for you guys if you do want to really pad your grade out and get a bunch of extra points. Picking up a project's a good way. That being said, have an idea what you might want to do. If it's something you do want to explore and kind of go above and beyond, super up for that. I can, give you some ideas if you want it. I'm open to that. It'll be kind of outside what the rubric that's on the syllabus, but we'll figure out some kind of amicable amount of points for that if anyone's interested. So yeah, feel free to email me if you want to do maybe a project. There's not a ton of time to do one, but if you're interested in that, shoot me an email and we can probably work something out. So, okay, I think that covers the logistics for the day. I do want to add one more caveat. And I mentioned this yesterday. This is definitely a new lecture today. Yesterday was mostly new. So if any of the rules seem a little fishy to you guys, call it out and we'll explore the rules, because there definitely could be errors in the rules I'm giving you today. I wrote them up earlier. I did a little bit of checking on them. I think they're consistent and they won't give us any, crazy unexpected behavior. But if something smells off to you, definitely say something and we'll explore it a little bit. This is kind of the fun part of doing language design, is sometimes you get it wrong and then you get to explore, what are the weird consequences of it? Can you write a program that breaks the language? It's kind of a fun kind of red team, blue team kind of thing going on there. So if you notice that, please kind of, raise that, and it'll be some fun back and forth. I hope my rules are great, but who knows if they are or aren't. Oh, sweet. Any other questions before we get started today from you guys? I'll give you a second to type if you do while I write out our header. Okay, I don't see any questions. So today we'll start with, or it'll take the whole class, I guess, the semantics of commands. So yesterday we kind of talked about the behavior of commands, what we kind of expect imperative behavior to be like. And we spelled out the syntax for those, talked about that a bit, saw some edge cases. Now we're ready to probably start defining inference rules for those. We're going to kind of do what we did with type checking and executions before and try and work out the rules. We'll be using operational semantics here again. So remember that down arrow syntax. But we'll have to introduce some new notation here. So first thing is we have to introduce memory stores. We'll use the letter mu in our formal notation. That'll be what represents our memory store. So different than gamma, different than sigma, right? I'm realizing in my notes I use gamma everywhere, and we're actually supposed to be using sigma today. Yeah, so we have mu. Mu's are stored. It's gonna basically be, what is mu? What is a memory store? A memory store will be a map or dictionary from assignable strings to values. Okay, so this will look just like our gamma and sigma from before. You'll use a dictionary to implement those, like we've seen. I don't think I have too much more to remark. The notation might be a little bit different. So I think for mu, when we have a lookup, we'll kind of work it like a function. So we'll say something like mu of A equals V and then we'll use the old extension notation that we used with sigma. So not the gamma notation, we'll use something like mu, and the extension will be A maps to V, something like that for extending it. Any questions about the notation so far? Nothing. Quiet chat today. Let's keep that active. But I guess if there aren't any questions, there aren't any questions. So I have a question for you guys. Remember the form of our judgment. Let's do. So for operational semantics, remember that's the semantics of execution. We used to have the form sigma entails some expression E evaluates to some value V. So this pronounced in English under environment sigma, the expression E evaluates to value V. Okay. Is this going to work for commands? That's my question for you guys. Why or why not? What other considerations do we need to take with commands? Any ideas? And maybe I'll lead this with another question. If I modified our notation a little bit where E was some command, does this notation work? That's maybe another way to phrase the question. Or what might be missing from this? If we're executing commands and we have to keep track of state, where in this notation am I keeping track of state? Yeah, so Ronak says sigma. Am I really keeping track of state in sigma? Because sigma is actually just storing values that I've assigned, right? To different kind of variables, but they're not allowed to change. You know, sigma is not, you know, there's not state updates to it, right? Like I never get an output sigma per se. Maybe I'm not keeping track of state with this notation yet. So maybe I need to update my notation a little bit. So instead here, we're gonna, instead of just having sigma passed into this notation, we're also gonna give it mu. Okay, and this is gonna be just for commands. For expressions, it'll look a little bit different. So let's see how this is pronounced now. So under memory store mu and environment sigma, command, and we'll usually use C to denote commands, C evaluates to V. But I'm still missing something here. If I execute a command, will mu, our store, be the same after I execute the command, or will it be different? if I execute a command with side effects, remember, because command can have side effects, it can affect memory. Will mu be the same after I execute that command? Yeah, so Arthur says it definitely depends on the command, but we should probably represent mu differently before and after. I love it. That's perfect. So we're going to change up our notation a little bit. And there's a reason I didn't put, quotes there yet. Instead of just having a value as an output now, or on the right-hand side of that evaluation notation, we're also going to have an extra mu, some mu prime. And that's going to be the updated store. So under memory store mu and environment sigma, right here, command C evaluates to V and changes into memory mu prime. So that's how we can read it. I don't love the last part I wrote, but I think it gets the idea across. Yeah, so let's kind of break this down with a little bit more writing. So this is the command. We have the execution environment. We have a memory store. And this is the memory store before command executes. Then we have the value, if there is one. There won't always be a value here, which is interesting. And then mu prime will be the memory store after command executes. Any questions so far? No questions. Okay, so we're all following along, hopefully. If you get lost, say something for sure. Again, really quiet. It's scaring me, guys. Cool. So we've got this new notation. We'll see how it works here in a second. But the key takeaway here is that when we execute a command, we also will be getting not just a value. Most of the time we'll get a value, but we'll also get an updated memory store. Okay, this is exactly what Arthur's comment was. We should probably represent mu differently before and after, right? We have an input mu and an output mu, essentially. So there's one more thing I wanted to point out. We're also going to change our expression. So this is just for commands. Put that up here. And I'll put it actually a little lower. Just for commands, not expressions. Okay. Oh man, why tilde? Why do you have to say stuff like that? Could I state it in iambic pentameter? I'd love to, but give me a day or two and I'll come up with something for you. I'd have to read some Shakespeare, get inspiration first. So where this is going is we have a different new notation for expressions. So expressions are just going to be slightly modified, where we have mu and sigma entails E, down arrow, V. And that's it. That's the same notation. So all I've done is added a mu. So same as old notation, except an input mu is added. Okay. This is for expressions. Right, for up here for commands. So we've essentially introduced kind of a new form just for commands. We have this slightly different form for expressions. And all the rules from before with expressions will be the same. The only difference will be this new rule we're about to write to handle blocks. Okay. Questions thus far? Need a second to type, go ahead and take it, but otherwise I'm gonna start writing the next header. Okay, no questions. I'm going to keep moving. So we have at least one new rule for expressions. Okay, so remember that we added blocks to the language. These are those imperative blocks from yesterday. So, and I'll keep doing our little reminder text on the side. So blocks will have the grammar of block, and then it will take a command as an AST. We'll write this block, and then the variable we'll often use will just be C for command. And concretely, this will be our curly braces with C inside. Hopefully this still kind of, everyone remembers all this. Arthur, is that an iambic pentameter? That's amazing if it is. All that he has done is add, no, that's not right, I don't think, is it? Correct me if I'm wrong, that'd be really impressive. If you guys aren't keeping an eye on chat as class goes, you're really missing some top-notch content here. Just want to say that for sure. I don't know, I think iambic pentameter is pretty impressive, Arthur. I don't know about you. Sweet, so let's do the rule for blocks. So the form of our rule is just going to take that updated form I just gave you a second ago. That line's not straight. So we're going to have now mu. Oh, no, darn it. I can't draw a straight line today. There we go. So we'll have mu and sigma entails that block C evaluates to something. We don't know what that's going to be yet. How are we going to evaluate a block of commands? What do we need in the premise? This is actually a pretty easy rule as far as rules go. And I'll give it to you just while we're still getting kind of warmed up. All we're going to do here is we're going to basically pass this evaluation along to the rules for commands. So we're going to say that under mu and sigma, if C evaluates to some V and some mu prime, then this whole thing evaluates to that v. Okay, so we'll throw away mu prime here. We won't even use it. All right, so I'm actually just going to cross it out and put like a little dash there. That dash just means it doesn't matter. It's irrelevant what that is. Everyone with me so far? Sweet. So that rule's pretty straightforward. Now we can start talking about the rules for commands. Oh, that line's not straight either. What have I done? That's better. So now we're on to the rules for commands. What do you guys want to start with? So we have 6 commands we could do. We have return, we have declarations, we have get, set, sequence, and while. What do you guys want to start with? I'll let y'all pick. So Conlon says while. Let's do while last for sure, Conlon, because that one's the most kind of complicated. So other than while, pick any of the other ones will be fine. No one want to pick? I mean, I'll pick.
Could you scroll up just a bit to that last rule?
Oh yeah, sorry. I guess there you go. Sweet. So let's just do get, I guess. Nah, let's do return. We're gonna do return. So start with return. And here's a reminder of the form. So we have, as a grammar, return is written ret exper, and it takes an expression. And then as an AST, we'll write this ret e. And as a concrete, or in concrete syntax, we'll usually write return e. Okay. How might we write this rule? So we're going to start with our normal boilerplate. So mu sigma entails ret e evaluates to, and then because it's in this different form, we're going to definitely get 2 things. So now we have, the updated store and the value. Now what should return spit out? How do we get those 2 question marks dealt with, I guess? We're going to do something relatively simple here. So with a return, all we need to do is evaluate this expression. Okay, so this one's actually a pretty straightforward rule. So we have mu sigma entails e down arrow v. Okay. Returns can't affect our store at all. Okay, so there can't ever be any updates to the store within a return. All it's doing is returning stuff. So we have v, and then we have mu as the returned store. Very straightforward here. Okay, let's keep moving. Let's go ahead and do set next. For set, we have it in its grammar, AST, and as concrete syntax. As a grammar, this will look like set with a string and an expression. And then as the AST, we'll have set something like A and E. Concretely, this will look like A colon equals E. Our rule. Start with our normal boilerplate. So under mu and sigma entails set AE evaluates to what? Okay, so it's commands. So we know it's going to give us an updated store and maybe a value as well. All righty, so what do we need to do here? I'll wait till somebody kind of takes a stab at it. So what should this evaluate to right there? Maybe if I gave you a program concretely, we could start talking about it. So here's a block. We'll pretend we have a declaration. So declaration A equals 5 in A equals 10. Okay, and I want you to tell me how to evaluate this part. So tilde says v and mu prime. So yeah, so let's go ahead and put a v and mu prime, and then we can figure out how to fill that in. So we have a v here. We have a mu prime here. What should we do up top? Okay, so we need some more premises. What do we need? How are we going to get this v and this mu prime?
Decal is a command, so I assume that as a premise it would return a v and a mu prime.
Oh, I see. Yes, and that would have already happened. Kind of at the point where we're getting to a set. We should have done declarations first. So yeah, I guess I may sort of could have left that first line off if I wanted, but maybe not to. So if 10's an expression, what do I need to do to 10 in order to add it to our store? Because 10's an expression right now, and our store takes values. So how do I get 10 into a value? We evaluate it right on pseudo. So we're going to evaluate 10. So under mu and sigma, 10 here is this E, right? So we have E down arrow. And because it's an expression, all we need here is a V. That gets us our V. Okay. But now I need to ask you guys, where do we get mu prime from? Because mu prime needs to be kind of updated so that A maps to that value, right? That A maps to V. So you could write this a couple ways. I'm going to write it, I think, this way, where actually we just have mu and A maps to V. Does that sound good to everybody? We could have also written this in a little bit of a different style. So I'll put that note there too. So alternatively, we could have written the same first part, and then we could have said, kind of kept around that mu prime here, and said that mu prime is equal to mu extended with A maps to V. Okay, those are the same. Both are sufficient for me. So Tsudo asks, do we really need mu prime in that case in the other rules? Could we not just return mu in the other cases? I don't quite understand what you're asking. Can you elaborate a little bit? That would help. I'll give you a second to type while I write the header for our next set of rules. Next, we're going to do, we just did set. So next, let's do get. With the grammar, the abstract syntax, and the concrete syntax. The grammar for get is get and string. As an AST, this will probably just be get A. And then the concrete syntax is that at sign notation, so at A. And pseudo types, some clarification. So in the other rules, we use mu prime, but we could have just returned mu as we've returned mu plus A to V in this rule. Let's see. Also, we use mu prime, we could have just return mu as we've returned mu plus A to V. So do you mean more like I've written it here? Because I think that's what you're saying. Or maybe the distinction is that mu prime here is actually something we are, okay, cool. Yeah, so mu prime here is something that this is where the actual manipulations take place too. Whereas in other rules, sometimes they defer to different rules to make the changes. So if we have like a nested set, that's going to be handled by a set rule. Say if I'm inside a sequence block or something. So cool, glad that makes sense, because I was not understanding your question otherwise. So cool, so let's talk about get. Another rather simple rule. I'll start by writing the line and the base form. So we have mu and sigma and tails. Get A evaluates to some updated store and some value. Now, what needs to be true for this? So let's say I have a program that looks something like this as a concrete example. So I have something like declare, or how was I writing that yesterday? Was it declare? Or, oh, I wrote new. So that notation I used above is a little off. So new A colon equals 2 plus 2 in, and then I have something like maybe A is equal to at A plus 1. And then there's probably going to be more program there. So, but how do I evaluate this part right there? I guess the part in yellow. Now it's in orange. What do I need to do here? What do we think? Any ideas? If I encounter an assignable and I say, get the value at this assignable, what might I put in the premise of my rule? What might I do with that A in order to fill this rule out? We're just going to go get A, right? So because this is a dictionary, we can do a lookup. Or rather, because mu is a dictionary, we can do a lookup. So I'll write this in this style this time. Mu of A equals some V. Okay. And then given that, what's my output going to be? What should go here in orange? I will wait for you this time. Quiet chat today. What ought to go in the orange there? V and mu, right on, guys. Mu because mu's not changing here. And V because that's what we needed to retrieve. So right on, I like it. And that's the rule for get. Arthur, thanks for typing it all out. Your Greek typing is getting really good. I like it. Next, we just need you to get the math symbols done, which isn't too bad. If you're doing the Greek, the math symbols are easy. All righty. So we've done what? Get, set, and return. Let's do declarations now. Declarations are going to be pretty familiar to us. So remember, these are allocations, so kind of like malloc, a little bit like malloc in C. As a grammar, as an AST, and concretely, the grammar is decal with a string, an expr, and a command. The AST is decal, and we'll write A, E, and C. And concretely, this is that new A colon equals E in C. All righty. So let's give us an example here. So in this block, we have something like new A equals 10 in return A. How might we evaluate this? You know, we start with our normal boilerplate, mu and sigma, entails ret. No, not ret, entails decal. AEC evaluates to some value, some mu. We don't know what those are yet. Okay, how do we handle this? Does anyone think this rule might look a little bit like a rule we've already seen? And if so, what rule might that be? Yeah, so pseudo says set, and that's pretty much because we're setting a value here, right? So intuitively, that makes a lot of sense. How will this be like set, do we think, in terms of the premise? We're going to end up using part of the same premise. We're going to evaluate that E to start. So we're going to have under mu and sigma, V dash E evaluates to some value, V. Okay. And now where this gets a little different is then we execute the commands that are nested inside the declaration. Okay, so we have kind of an automatic sequencing happening here, right? And so where this gets different is, let me find the rule on my note sheet. We're going to have mu under A maps to V, and sigma, we then evaluate C. And from C, we will get some other value, V prime, and some mu prime. And then it's those two values that we're going to have on the other side of this rule. Right? So in English, it says, if I encounter a declaration, let's evaluate the declaration's value, E, in the sum value, add it to the store, and then execute the rest of the program. Okay, and then just forward along that execution. So this isn't really very much different than a let binding, except we're just doing it with mu, right? So very, very similar in that respect. Actually, I think it's almost identical rule, except we have to pass the store around here, and we didn't have to do that in the past. Awesome. That's our declaration rule. And let's talk about the kind of most important rule now. That kind of does all the heavy lifting, and this is the sequencing rule. That's that semicolon. Okay, as a grammar, we said this was SEQ, command. As an AST, we'll write this SEQ C1, C2. And concretely, this is C1 semicolon C2. Now this is it's a fairly straightforward rule for the most part. Once you kind of figure out how it works. So we have the same kind of boilerplate. with SCQ, C1, C2, evaluates 2, and then what should go there? So I'm executing command 1 and then command 2, right? So if I'm executing these in order, I do this one first, and then I go to C2. And C1 is probably going to change the memory store. So we better pass the updated memory store along to C2. So let's start writing this out. So we have for command 1, mu and sigma. And we have C1, down arrow, evaluates 2. Some value and some mu prime. Okay. We're not going to use this value. So I'm just going to put a dash there. We don't use it. And Arthur's a step ahead. We're going to end up with a mu double prime here in a second. So now that we've executed C1, we're going to execute C2. Much in the same way, except here we give it mu prime and sigma again. And here we do care about the value, so we'll get a V and mu double prime. And then can anybody tell me what goes in the question marks now? Yeah, so Linnea is saying V and mu double prime, right on. I like it. So we have V here, mu double prime. And that's our rule for sequences. And this is the one that kind of allows us to do a lot with our store, right? The rest of the rules are all fine on their own. They're very simple. This is the one that lets us chain stuff together and actually do stateful computation. It's this passing of the store along. And actually, I think I'll write a note about that. This rule captures the idea of passing along the state. I square up with everybody? We're liking this? Cool, cool. Any questions now that we've gone through all that before we jump into while? Because while's a doozy. Otherwise, I'll start scrolling. So let's do while loops. Sure you guys know this notation, but we'll rewrite it still. So here is a grammar. We have while. While will take 2 commands. This is an AST. We write while C1, C2, and concretely, we write while C1, open a block, C2. And usually that block will be multiple lines, right? Now, for starters, this is going to have 2 rules. Can anyone take a guess at what the 2 rules are going to be? Any guesses? It's a pretty obvious place where we could split while into two cases, I think. So C1 and C2, not quite. There's actually something about C1 that should give us two different rules. So if you think about how a while loop behaves, it has two kinds of main behavior. What are those? Yeah, so Pseudo's got it. It's when C1 is true, and in the other case, when it's false. So 1 for C1 evaluates to true. This is the continue case. And there's another for C1 evaluates to false. And this is the break case, right? Let's start writing these rules. Let's start with the break case because it's nice and simple, comparatively to the other one at least. So I'm going to have, a mu. My mu's are getting worse as the day goes. Mu and sigma entails while C1, C2 evaluates to, and we have double parentheses, or parentheses again, not double parentheses. Should just be one set. What should I have up top here? What should I be doing with C1 is really the question. Yeah, so basically a bunch of people are saying C1 evaluates to false, right? On top. So under mu and sigma, C1 down arrow, false for the value, and mu prime. And the mu prime is there is because we could have updated the state while executing C1. So we do want to allow for state executions there. And then in this event, we don't actually pass out any value. This is going to be the interesting part about whiles, is there has to be a return. If you hit a false case, there has to be a return somewhere else outside of the while loop. So we'll leave that blank. And then on the right-hand side, we pass along mu prime. Nice straightforward rule. Perfect. Good work, guys. Now, how about for the other case? Now, the beginning of this case should seem fairly simple. So this is going to be for continue. We have our same boilerplate, mu and sigma, v dash, while C1, C2, down arrow, and we'll have some kind of output maybe. We need the opposite case here. So we're going to start with the kind of the same premise, mu, comma, sigma, v dash, C1, evaluates to, this time the true case, and mu prime. But what do I do from here? So Arthur asks, what does mu prime mean? In this case, the program encounters the while loop and C1 is immediately false. Then wouldn't mu prime not have a value inside it yet? Or does the mere act of evaluating C1 result in result in a mu prime? It's the second case, Arthur. So just the act of evaluating C1 will update mu. Because we allow for any arbitrary commands to be in there, so long as they return a Boolean. This is just for expressivity's case. Very rarely would you probably ever want to do that, but we'll allow it. It just makes our language more powerful. So, and then Linnea says mu prime sigma, and then we're going to do C2. So mu prime. C2, down arrow. And then what goes over here? Does it need to be anything special? Or can we just give variable names here? So for the first value, for the value itself, we actually don't want anything. So dash, and Conlin's got it. It's going to be a dash. We're going to forget about the value and then get mu prime. Conlin, are you looking at my notes again today? Oh, and I guess Arthur typed it right before that as well. So kudos to both of you. Are we done? Or do we need to keep doing stuff here? So, and then pseudo says, so we return the whole while C1, C2 with the U double prime. And then, oh, a lot of answers here. Yeah, pseudo's capturing it for sure. So we want to execute the while loop again, like jumping back to the beginning of the program. How are we going to write this? So we're going to write this. It's going to execute under mu double prime and sigma again, entails. And then we're going to write while again. And we're going to have while C1, C2, down arrow, and then there will be some output. This is effectively doing that kind of looping behavior. It's saying, re-execute this, execute this again. We don't want to output it per se, right? Because we still want a value in a store, but we're going to just have it as a premise in the rule. Say, hey, do this again until we get the false case, and the false case will bottom us out. Okay, this is going to output some value and some mu double prime. Or sorry, triple prime. And then that becomes our output for the while case. Does this square up with everybody? We like this? Hopefully it captures the behavior that we want. I think there's actually an error in it, but I don't think I'm going to bring it up until Tuesday. So can anyone guess where the error might be here? Or some expected behavior that won't behave in the way you think it will? Let's try and immediately break our rules. Any guesses? So I have a question for you guys, and I'll actually leave you with this. I won't answer it yet. What if I write a program? That's not the color I write programs in. What if I write something like this? While, I don't really care what's in here. And then in here, before the while loop's done, I might have stuff before and after it. I have a return like 5 in the middle of the loop. Answer your question, Arthur. I don't believe so. It will be the triple prime. And Arthur, to point it out, the reason why is because when we get to this rule, this will be kind of the final updated mu. It passes it through, and then that gets passed along to here. So what would happen here when we have a return, something like return 5? It's supposed to be a 5, not an S. In the middle of a while loop, we would expect that to return 5 for the whole program, right? But as we've written this program, that doesn't happen. Can you tell me why? So why doesn't return, terminate the loop early? I'll leave you guys with that until Tuesday. If you can answer that question on Tuesday, there might be bonus points in if it's a satisfactory answer, because this is not an easy question to answer either. So, yeah. Yeah, so pseudo, you say there's not a rule for catching it in the middle. That's correct. But what happens actually when you have a return 5? I actually want to know how it behaves. So try and carry out these rules, guys. And I'd like an answer for it on Tuesday. Let's see what that looks like. So what does a program like this actually end up doing given the rules we've just written? So, and I'll upload these rules to Canvas so you have them. Other than that, if there aren't any other questions, I will turn you guys loose for the weekend. Enjoy. Reminder, homework 5 will be out a little later tonight. Otherwise, I'll see y'all on Tuesday.
Thank you.